Hello children, in this video we will be discussing the graphical representation of one-dimensional motion. Children, let us recall what is one-dimensional motion. Children, if any object is going along a straight line path, such a motion is called linear motion or rectilinear motion, or simply we can call it as a one-dimensional motion. Children, this one-dimensional motion can be well understood with the help of graphs. Here we will be discussing mainly about three types of graphs. First one is displacement time graph and velocity time graph, and third one is acceleration time graph. But dear children, one very important thing is that in one dimensional motion, I mean the objects are going along a straight line path, which means what? There won't be any change in the direction. So we no need to think about the direction, as all the bodies are going along a straight line path. So in that case, dear children, the magnitude of displacement and distance are same, and the magnitude of velocity and speed are same. That's what displacement time graph or distance time graph, velocity time graph or speed time graph. These all are same only. But dear children, what is the use of the graph first of all, dear children? So graph will give you the relation between two physical quantities. I mean, we can understand how one quantity can vary with the help of, with respect to another quantity. But dear children, as we need to make a graph between the two physical quantities, which one should be taken on x-axis and which one should be taken on y-axis? Very, very important. Children, remember one very, very important thing is that here, whenever we are making a graph on x-axis, always we should take the independent quantities. Very, very important. On x-axis, we should take the independent quantities. Independent quantities should be taken, whereas on y-axis we will take a dependent quantities. We will take a dependent quantities. So as we are going to discuss about three types of graphs. One is displacement time graph, first one, and the second one is velocity time graph, or even we can say that speed time graph also, and third one is acceleration time graph. Dear children, in these three types of graphs, the time is a independent one. I mean what? Either distance or displacement dependent time, your speed or velocity dependent time only, and acceleration also depends on time only. So which means what? Always time is taken on x-axis, whereas displacement, velocity and acceleration, so they will be taken on y-axis. Why? What is the reason? Because they are dependent. So it's very, very important. Always independent quantities are taken on x-axis, whereas dependent quantities are taken on a y-axis. This is very, very important. That is fine. Then dear children, how can we calculate the slope of a straight line? This is very, very, very important. Let us recall once again, how can we calculate the slope of a given straight line, and when slope can be positive, when the slope can be negative, also very important. This concept, this point is very, very useful to us when we are solving the numericals. For suppose, dear children, let us take, here we got one graph like this. Let us take, here is x-axis and here is y-axis. For suppose we got a straight line like this. Let us say here is AB is a straight line. And the first and very, very, very important thing is that always, dear children, whenever we are measuring the angle made by the straight line, we have to take from x-axis in anti-clockwise directions. Very, very important. Always the angle is measured from the x-axis in anti-clockwise direction. Such an angle is taken as a positive. If you can take in anti-clockwise direction, that we can take as a negative. And for this slope, for this graph, dear children, how can we calculate the slope? The very simple thing is that, dear children, you consider any 2 points on the straight line. You can take, for example, let it be, it is one point P, and let us take one more point is a Q. From here, dear children, okay, this let it be here theta here. So from here, let us take, here is a x coordinate, let us say x1. For the corresponding y value is, it is a y1. Similarly, and this at this point, the value of x, let us say it's x2, and the corresponding value is, corresponding y value, let us take it as a y2. Then how to calculate here? Slope is equal to y2 minus y1 by, here is x2 minus x1. Achha. And y2 minus y1 is what, children? It is a change in y value. x2 minus x1 is what? Change in x value. So, this can be written as dy by it is dx. And what is the dy in this graph? Let us see the children. So, from here we can make one triangle. Let us say the P, Q. Let us say this point is O. This point is O. Which in this graph, dear children, this will represent dy because change in y value, whereas this will represent change in x value, that is a dx. This is a very important thing to understand. Means what here? Dy by dx. So, dy is what? Nothing but it is OQ, that is here is OQ. Let me write here. It is a OQ or QO by this is dx is what? It is a OP or PO we can take. It is PO. But dear children, if you can take here, this is a triangle. So, here is a triangle POQ and this will be a what? Here is a theta. Angle, this is a theta. Obviously, this also will theta only. Dear children, from this graph, if you can see, tan theta is equal to what can we write? Tan theta is equal to opposite side by adjacent side. It's very, very important. Tan theta is equal to, that is QO by it is a PO. I mean, QO by PO, what can we write, dear children? In the place of QO and PO is nothing but actually it's a tangent. It's a tan theta, which means what here? Slope is equal to tan theta. By finding the tan theta, we can find the slope of that particular graph. Slope of that particular graph. But when the slope will be positive, when the slope will be negative, also very important. Dear children, we have to see whether the angle made by the straight line is an acute angle or obtuse angle. So, what happens when it is an acute angle and what happens when it is an obtuse angle? For example, dear children, so let us take a graph. We got something like this. Here is x-axis and here is y-axis. So, we got a graph like this. Let us say in first case. Whereas in one more case, dear children, let us take here is it's x-axis and here is y-axis, and we got a straight line like this. So, then what will be the slope? I mean, when the slope will be positive, when the slope is a negative is also very, very important here. So, dear children, if you can see here, the angle made by the straight line with the x-axis, how we will take? From here we will take. Here is a theta. In this case, this is a theta. But whereas in this case, dear children, can we take like this? No, that is wrong. Because already I told you that always angle must be taken from x-axis in an anti-clockwise direction. X-axis in an anti-clockwise direction. So, here we need to take an angle like this. We take this is a theta. Means if you can notice, dear children, here is a theta is a acute angle, whereas here a theta is a obtuse angle. Which means what here? Here is theta is less than between, like in between. It's very, very important. In between 0 and 90 degrees. Whereas here, dear children, here theta is in between 90 degrees and 180 degrees. 90 degrees and 180 degrees. I mean, for these values, dear children, for these angles, tan theta is negative. Very, very, very important. That is negative? No, it is a positive. So, tan theta is a positive. I mean, you can take a tan 30, tan 45, tan 60. Okay, these all are positive values only. Whereas, in this case, dear children, tan theta values, I mean, tan 135, okay, even you can take a tan 180, see, these all are units of negative values only. So, here, tan theta is going to be negative. But tan theta is what, dear children? Tan theta is nothing but the slope. So, as tan theta is a positive, we can say that slope also positive only. Here, as a tan theta is a negative, we can say that slope of the graph is negative. Only two things, dear children, we have to remember only two things. What is that? Whether angle is acute angle or obtuse angle. If the angle is acute, obviously slope is a positive only. Whereas, if the angle is obtuse, then it is what, dear children? The slope is negative. So, this is how actually we can decide when the slope is going to be negative and when the slope is going to be positive. So, these points are very important when we are solving the numericals, especially based on the graph. Very, very important. Okay, fine. Now, dear children, we will see one by one how the displacement time graph will be in a different situations, whereas how the velocity time graph will be, and finally we will be discussing about acceleration time graphs also. So first we will see what is the displacement time graph, from that what can we calculate, and how the displacement time graph will be in a different situations. The first one is, let us see here, it is a displacement time graph. Displacement, and here is time graph, displacement time graph. Children, the very important thing is that from the displacement time graph we can calculate the velocity. But how can we calculate it, children? The slope of displacement time graph gives velocity. So by finding the slope of displacement time graph, we can calculate the velocity. So here whenever we are making a displacement time graph, dear children, so which one should be taken on x-axis and which one should be taken on y-axis? Very important. As we discussed that time is an independent quantity, should be taken on x-axis, whereas displacement is a dependent quantity, that is it depends on the time, that must be taken on a y-axis. Now dear children, under this displacement time graph, we will see the first case, dear children. Let us see the case 1. Let us see the case 1. For example, dear children, here is a wall, something like this. Let us say that here is a wall. Fine. And let us take here is one vehicle. Let us say here is a car or something. It is a vehicle. So it is parked. It is at a vehicle. And here is a ground, let us say. Dear children, it is at a distance or a displacement. Children, as it is a one-dimensional motion, distance and a displacement both can be taken as the same. Let us say it is, for suppose it is a 10 meters. 10 meters. And we are noticing that initially when we started observing the car, let us say time 0 we will take whenever we start observing the children. So it is at a 10 meters displacement, or it is at a 10 meter distance from this wall. After 1 minute, same thing. 2 minutes, 10 meters. 3 minutes, 10 meters only. After 100 minutes, also it is at 10 meters only. Which means what, children? The car is not changing its position. Which means what? Obviously, the car is at rest. So, this is a case where object is at rest. Object is at rest. Which means what? As time is passing, but there is no change in the displacement. The object is not changing its position with respect to the surroundings. Here, we will take wall as a reference point. With respect to the wall, dear children, the car is not changing its position. Then for this, dear children, in this case, how the displacement time graph will be? Look at here. Here is, let us take, here is time is taken an x-axis because it is independent, whereas here displacement is taken, displacement or distance, anything is okay because it is a one-dimensional motion, can be taken on a y-axis. Here, dear children, for example, here 0, it is 1, 2, 3, 4, means you can take a time on x-axis, and here is, it is 2, 4, 6, or else let us take like this, it is 5 meters, it's a 10 meters, here is a 15 meters, means displacement is taken in meters. Initially, when the time is 0, yes, the body displacement is 10 meters. After 1 minute, yes, after 1 minute, the displacement will be 10 meters only. After 2 meters, so you will be getting all the points, look at here, teacher, same line. Means after 4 minutes, same thing we will get. Try to connect these points here. So what do we get here? We get a straight line. We get a straight line which is parallel to the time axis. It's very important. So whenever the body is at rest, for that, how the displacement time graph will be. So what type of graph do we get? We get a straight line but parallel to the x-axis, which means what, children? As time is increasing but not a displacement or but not a distance, which means what? Which means the body is at rest. Children, for this, look at here. What is the velocity of the body here? Of course, we can say that as a body is at rest, obviously there is no change in displacement. As there is no change in displacement, the velocity of the body is 0 only. But mathematically, how can we? We know that by finding the slope of a displacement time graph, we can calculate the velocity. So here also let us try to calculate it, children. For example, here slope formula we know that slope is equal to y2 minus y1 by x2 minus x1. Children, for suppose if you want to take from here to here, let us take. So let us take x1 is here 0, x2 will be, what is the children? It is a 4. I mean here 4 minus 0. So at this 4 children, what is the corresponding y value? It is 10 only. Whereas when the x1 is 0 at this point, what is the corresponding y1 value? Again it is 0. What? 10 only. I mean what it is a 10 minus 10 only. That is 0 by 4. 0 by 4 is what children? 0 only. So what does the slope of displacement time graph represent? It's a velocity. So we can say that velocity of the body is 0. Velocity of the body is 0. Of course, for this we don't need to do mathematical and we don't need to find out the slope and all these things. So very clear, as the body is at rest, which means what? There is no change in position. As there is no change in position with each children, the velocity will be 0 only. But mathematically also we can prove that the velocity of the body is 0. How can we prove? By finding the slope. Okay, fine. Achha. Now let us see the case 2. Let us see the case 2, where now the body is changing its position with respect to surroundings. The body is going along a straight line path. For suppose teacher, let us take a case. So here is, let us say straight line path. The body is moving like this. Now it is moving such a way that children. So the displacement is changing continuously. So as we know that whenever the body is changing its displacement, obviously the body will have some velocity. But what type of velocity? Let us see one second. Children, here at a time, let us say it's a 0, after 10 seconds, like a 20 seconds, 30 seconds, 40 seconds, the displacements are like this. I mean, so from 0 to this one means initially when the body is at rest, when the body is like initially the moment when we are starting observing the children, let us say its displacement is 0. After 10 seconds, yes, it has covered 10 meters. After 20 seconds, 20 meters. 30 seconds, 30 meters. 40 seconds, 40 meters. Dear children, if you can notice here, dear children, the change in the displacement is the same. I mean what? The body is covering equal displacements in an equal interval of time. Children, whenever a body is covering equal displacements in equal interval of time, then we can say that that body is moving with a uniform velocity. So the second case, whatever we are going to study, the case for what, children? Uniform velocity. Means when a body is moving with a uniform velocity, dear children, how the displacement time graph will be? How the displacement time graph will be, and how can we calculate the velocity in that case? Let us see. Children, here is, let us take, here is a graph. So on x-axis we should take a time, on a y-axis displacement, it is in meters. It is in a meters. Let us take, it is 0, it is a 10, it is 20, it is 30, it is 40, and here is a 50. And a distance or a displacement on y-axis, that is, here is 10, here is 20, 30, and here is a 40. So initially, when the time is 0, dear children, displacement is 0 only. Means here is a point we will get. After 10 seconds, the displacement is 10 meters, so the point will be here. Whereas after 20 seconds, dear children, the displacement is here. Whereas after 30 seconds, here will be this one. So this is a point to represent like this. After 40 seconds, dear children, after 40 seconds, here we will get. So there is the point which we will get. Now try to connect the lines. So we get, here is straight line. We will get a straight line passing through the origin. Children, it's very important. It's very, very important. So here, whenever we get a straight line which is passing through the origin, and moreover, which is making, dear children, the angle is, look at here, this angle is obtuse angle. Is it obtuse angle? No, it is an acute angle. It is an acute angle which represents what, dear children? The body is moving with a uniform velocity away from the starting point. It's very important. Means it is not coming back from the it is not coming back to the starting point. It is moving. It is moving away from the starting point. With what? With the uniform velocity. So children, this is how actually the displacement time graph will be if an object is moving with uniform velocity. Then how can we calculate velocity, children? You can calculate the velocity by finding the slope. So we know that again. Children, in this case, let us calculate the velocity. What is the velocity of the body? Children, here slope is equal to, how can we calculate the velocity? By finding the slope. That is slope of slope of displacement time graph, the slope of displacement time graph gives velocity. So this point we should not forget. The slope of displacement time graph gives velocity. So children, look at here. You may take here from here to here. Let us take here. Okay, na? So here, what is the x1 value? What is the y1 value? Children? So here is the starting point. So at this point means it is the origin. So its x1 will be 0 only, y1 will be 0 only. That is here x1 is equal to y1 is equal to 0 only. Then what is x2 value, dear children? So this will be x2, that is a 40, and here will be y2. It is also 40 only. That is here x2 is equal to 40 only, and here is y2 is equal to 40 only. Y is equal to 40 only. And don't forget that here an x-axis which we have taken time. So it is the 40 seconds, and y2 we have taken displacement. So it is a 40 meters. Now we know that slope is equal to y2 minus y1 by it is x2 minus x1. x2 minus x1. So here is, let us substitute the values. 40 minus 0 by here is 40 minus 0. This will be 40 by 40. You will get a 1 meter per second. Additionally, you can calculate the slope at any point. You will get the same value for velocity. Which means what here? Body is moving with uniform velocity. Even you can take O2, let us say this point A. Same you will get here. I mean here x1, y1 will be 0, but x2 will be 20 and y2 will be 20. That is 20 minus 0 by 20 minus 0. Again it is 20 by 20, again it is 1 only. So at any point you can take, at any point you can calculate the slope, you will get the same value. That means what? The slope of displacement time graph at any point remains constant, which means what? Body is covering equal displacements in an equal interval of time. Then we can say that body is moving with a uniform velocity. Whenever a body is moving with a uniform velocity, children, we will get a graph, that is we will get a straight line which is passing through the origin. And don't forget that here the body is moving away from the starting point. How can we say that? Because here slope is a positive, that is it is a acute angle. Acute angle means what, teacher? Slope is a positive. So when the slope is positive means what here? Displacement is increasing. Displacement is increasing from starting point. Now we will see the third case, dear children, where the body is moving with the variable velocity. Let us see the case of 3. It is a third case, dear children. We will see that where the body is moving with the variable velocity. So if a body is moving with the variable velocity, how the displacement time graph will be? Variable velocity. Children, where you can say that body is moving with a variable velocity. Children, if a body is not covering equal displacements in equal interval of time, then we can say that body has variable velocity. Children, actually this is the most common thing actually. It means so practically we know that no object can travel. I mean practically. So in our day-to-day life, dear children, so generally do you think that the bodies are covering like a equal displacements in equal interval of time? It is not that. Obviously there will be a continuous change in the displacement with respect to time, but not in a same manner. That's what we can say that bodies are moving with the variable velocities. So children, if a body is moving with the variable velocity, how the displacement time graph will be? Here is, children, is a time and here is a displacement. So whenever the body is moving with variable velocity, children, so we don't get a linear graph, rather we get a non-linear graph. We will get a non-linear graph. Then as we are getting a non-linear graph, then how can we calculate velocity? Can the velocity will be same at the same point? No, obviously it is not. The velocity is not a constant. The velocity is changing. The velocity will be changing continuously. But how can we calculate that velocity? Teacher, for suppose here is, let us take here is 0, 1, it is 2, 3, 4. Some values are given. Here also some 2, 4, it is 6, this y. Then how can we calculate velocity from this, children? So here at any point, just to draw the tangent A, B. It is A, B. Now for this is going to be x1 and this value is going to be x2 and this will be, or this will be exactly, so this is going to be, so this point, let us say 1 is going to be y1 and this is going to be y2. This is going to be y2. So again, let us apply the same formula, that is slope is equal to y2 minus y1 by x2 minus x1. Means at any point each length, by finding the tangent, means you have to draw the tangent and further you can calculate the slope. And it is very clear that each length, for different points, you have to draw the tangents and we will be getting the different values of slope. So which means what here? We will be getting a different values for velocity, which means the body is moving with the variable velocity. So it's very important. Whenever the body is moving with the variable velocity, how the displacement time graph will be? It is not a linear graph. Rather, it is a non-linear curve. It is a non-linear curve it is. By finding the slope of at any point for this graph teacher, we can find the velocity at that point and at that time. So what is the velocity which we will get each length? That is nothing but instantaneous velocity only. Because at that time it is, for example, at this point the velocity might be 10 meter per second. But next minute it may not be 10 meter per second. It might be 10.5 meter per second or 8.2 or 8 meter per second also. So this is how actually displacement time graph will be. And each children, one very important thing is that what type of graphs are not at all possible in a displacement time. Let us see here. First, suppose here is a time and a displacement. So here we won't get a straight line parallel to the displacement angle. Why? This graph is not possible, children. Which means here at this point the time is constant. As the time is constant, but displacement is increasing infinitely. Displacement is increasing infinitely. It is not possible. As the displacement is increasing infinitely, which means what? Velocity also increasing infinitely. Means at a constant temperature, it's a constant time, the velocity is increasing continuously. It is highly impossible. And even usually, look at here. Here is time axis and here is the displacement axis. So this kind of graph also is not possible. Why it is not possible? For example, at this point, at this time, let's say it's a time t1, okay now. So the body has displacement of s1, at the same time here also body has displacement of s2. Means with respect to the same reference point here, having two displacement at the same time is highly impossible. So in a displacement time graph, children, these kind of graphs are not possible. Clear? Fine. Now we will discuss the velocity time graph. What can we calculate with the help of velocity time graph and how the velocity time graphs are in a different situation? Let us see, children. So the second one is velocity time graph. Velocity time graph. Velocity time. Okay. Children, the very important thing is that by finding the slope of velocity time graph, means the slope of velocity time graph gives acceleration. The slope of velocity time graph will give acceleration, whereas the area under the velocity time graph, means by finding the area under the velocity time graph, we can calculate the displacement or distance. Displacement or distance. Children, this is very important thing. Very means very much important thing. Which means what here? By finding the slope of velocity time graph, we can calculate the acceleration. Whereas by finding the area under velocity time graph, we can calculate the displacement or distance. Now let us see the case 1. If any object, if any object is moving with a uniform velocity, let us take. So if any object is moving with a uniform velocity, how the displacement time graph will be? How the velocity time graph will be? Children, as the velocity is uniform, which means what? V value remains constant. Means for example, when a body is moving with 10 meter per second, at every second, at every point of time, the velocity is 10 meter per second, 10 meter per second. Means we are observing a car, let us say. The car is moving with 10 meter per second. After 1 minute, 10 meter per second. After 2 minutes, 10 meter per second. After 10 minutes also, if it is moving with 10 meter per second only. Then we can say that that particular car is moving with, or it has uniform velocity. So children, for that, how the velocity time graph will be? Look at here. So this is time axis and here is a velocity axis. So we get a straight line parallel to the time axis. So as we have taken example where it has a 10 meter per second, means as the time is increasing, as time increases, but velocity remains constant. Velocity remains constant. This is how actually we get a velocity time graph for an object which is moving with a uniform velocity. That is fine. But dear children, if the body is not moving with a uniform velocity, rather the velocity is changing in a uniform manner. If the velocity of the body is moving in a uniform manner, we can say that the body has some acceleration, that too it has uniform acceleration. So let us recall once again. What is the acceleration? The change in velocity means the rate of change of velocity is called acceleration. If the change in velocity is uniform, then the acceleration of a body remains constant. So in that case, how the velocity time graph will be? Children, it's very, very important. Even the children, examination point of view, if they want to ask the numericals based on the graphs, first priority must be given to the velocity time graph. Why? From the velocity time graph, we can calculate acceleration and as well as displacement. Children, let us take a case. For example, here is case 2 we will take and we will see how the graph will be. That is what here, it is a case of uniform acceleration. We are going to see the uniform acceleration. At the same time, we will see how can we calculate the acceleration and as well as displacement from velocity time graph. Children, let us take an example where at different timings 0, 1, 2, 3, 4 seconds. So the velocity is initial, let us say it is a 0 only. After 1 second, let it be 10 meter per second. So velocity is taken in a meter per second. Time is taken in seconds. After 2 seconds, it is 20 meter per second. After 3 seconds, 30 meter per second. After 4 seconds, it is 40 meter per second. Digital, if you can see, from here to here, difference is how much? 10 meter per second. From here to here, 10 meter per second. From here to here, what? 10 meter per second. Which means what here? The body velocity is increasing in a uniform manner. So, it is said to be moving with a uniform acceleration. For this, dear children, how the graph is going to be? Don't forget that here, body velocity keeps on changing. The body velocity is changing. What way? In a uniform way it is changing. So, body has uniform acceleration. For this, dear children, if you can make a graph, look at it. Let us make a graph. Here is x-axis, time is taken. Whereas on y-axis here is velocity is taken. Achha. Now let us take the values. So here is origin, let us say 0, 1, 2, 3 and here is 4. And let us take the values on y-axis. That is here is 10, 20, 30 and here is a 40. Now dear children, so when the time is 0, the body velocity is 0 only. I mean, it is a point. After 1 second, its velocity is 10 meter per second. After 2 seconds, its velocity is this one. After 3 seconds, its velocity is 30 meter per second. After 4 seconds, its velocity will be 40 meter per second. Now let us try to connect these points. We get a straight line. Of course, here something is missing. So here 20 means should be here 2. And 3 means here we should get here 4 second 40 meter per second, we will get like this. So now let us try to connect all these points. So we got straight line which is passing through the origin. And its angle is acute angle. Means slope is positive. So when the slope is positive, which means what? The slope of velocity is acceleration. So the body has positive acceleration. So this is how actually we will get the graph. If a body is moving with a uniform acceleration, children, this is a velocity time graph for an object moving with uniform acceleration. Now let us see then how can we calculate acceleration and as well as displacement from this graph. Let us see, children. So first let us try to calculate the acceleration from this graph. Acceleration. Children, how can we calculate the acceleration? By finding the slope of velocity time graph. Let us name it as a OA, or else let us name it as it's a O origin only, it is a AB. So we need to calculate the slope of AB. That is, look at here, that is slope of AB line. Children, we know the slope formula. What is that here? It is y2 minus y1 by it is x2 minus x1. Acha. Then what is x2 value and x1 value and y2 value, y1 value? Children, the graph is starting from this point here. here is origin. So x1 is 0 only and y1 is 0. Let us write here. So here x1 is equal to 0 only, even y1 also 0 only. What about x2? So this will be x2 is the 4 and y2 will be 40 it is. So here x2 is equal to 40, even y2 also 40 only. Let us substitute here, dear children. So this is 40 minus 0 by 40 minus 0. It is going to be 40 by 40. It is 1 meter per second square. 1 meter per second square, because here already is a velocity, it is measured in a meter per second only. So meter per second is going to be meter per second square. So this is how we can calculate the acceleration. Then how can we calculate the distance or a displacement from a velocity time graph? By finding the area. Children, the area under this graph, look at here. The area under this graph will give you the distance covered or displacement covered. Let us see here. How can we calculate the displacement? How can we calculate the displacement? Look at here. So how can we calculate displacement? Area under, children, it is a area under velocity time graph. Area under velocity time. Let us name it as a, so it is A, B, C. So ABC is a triangle, then we need to calculate the area of the triangle. That is here area of ABC. Children, we know that how to calculate the area of the triangle, half into base into height. So here this is going to be half into base is what? AC into this height will be BC. So from this graph, dear children, it is going to be half into AC value is how much? 4. BC value, this is BC. So this value is going to be how much? It is a 40 into here is a 40. So 2 1s are 2 2s are. So 2 into 40 is how much? It is a 80. So this is 80 meters. Children, this is how we can calculate the acceleration and as well as the displacement. Children, how can we calculate the acceleration? By finding the slope. By finding the slope, we can calculate the, slope of velocity time graph, we can calculate the acceleration. Then how can we calculate the displacement? By finding the area under velocity time graph, we can calculate the displacement or distance. Okay, copy it. Now, we will see, dear children. So what happens if a velocity of the body keeps on, of course, changing in a uniform manner, but if the velocity, like a change in velocity is decreasing, then we can say that, let us take a third case, dear children. It is a third case. Then we can say that body is moving with a uniform retardation. So it's very, very, very important. Retardation. It is a retardation, which means what here? The value of the velocity means the velocity is changing. The velocity is decreasing continuously. Means in a uniform manner. Then we can say that the body, children, it's a very, very important thing is that. So whenever final velocity is greater than the initial velocity, we can say that body has acceleration. Whereas if final velocity is less than the initial velocity, then we can say that, dear children, the body has retardation. So in that case, dear children, how the velocity time graph will be, let us see. For suppose, dear children, at time is equal to, let us say it's a 0, 1, 2, 3, 4. Same case let us take. Means after 1 second, 2 second, 3 second, 4 second. For suppose the velocity initially when we started observing, dear children, it has 40 meter per second. After 1 second, 30 meter per second. After 2 seconds, 20 meter per second. After 3 seconds, it is a 10 meter per second. After 4 seconds, dear children, the body velocity is 0. The body stopped, let us say. Then in this case, if you can observe, dear children, of course, so 40 to 30 here is 10 meter per second only. Okay. 30 to 20, 10 meter per second only. 20 to 10, 10 meter per second only. And here also change in 10 meter per second only. But dear children, here what is happening? The velocity keeps on decreasing. If you can see here, final velocity minus initial velocity, 30 minus 40, we will get minus 10. 20 minus 30, minus 10. 10 minus 20, minus 10. 0 minus 10, minus 10 only. Which means what? We are getting a negative values for velocity. which means what? The acceleration also negative only, which means what? The body is moving with retardation. And what type of retardation it has? It has uniform retardation, means the change in velocity is uniform. For this detail, if you can make a graph, how do we get? Look at here. So here is time is taken here, and here is velocity taken here, and here is 0, it's a 1, 2, 3, and here is a 4. As usual, here is 10 meter per second, 20 meter per second, 30 meter per second, and here is a 40 meter per second. Velocity is taken of meter per second. Initially, when the time is 0, the body has velocity 40 meter per second. Look at that. After 1 second, its velocity is 30 here. After 2 seconds, its velocity is 20. After 3 seconds, its velocity is 10 seconds. 4 seconds, its velocity will be here 0. Now let us join these lines. So when you can join this line, children, so we get a straight line. Again straight line only, but this time it is not passing through origin, children, and this time it is making an obtuse angle. Obtuse is very important, very important. So here this is a very important, children. So in this case, the angle is obtuse. As the angle is obtuse, children, tan value is negative. As the tan value is negative, obviously slope also is going to be negative. What is the slope of the velocity time graph? The slope of velocity time graph is a what? Acceleration, which means what? The acceleration has negative value. Let us try to calculate. Let us try to calculate the slope of this one. So let us calculate the slope. So slope is equal to, we know that it is a y2 minus y1 by it is x2 minus x1. What is the x1 value? What is the y1? Initial value. So initially here time is 0. I mean what here? x1 is equal to 0. Okay. And x2 value is how much? 4. x1 is 0, whereas x2 is 4. Fine. Now what is the y1 value? So here y1 value only. Children, y value on x-axis is 0 only. That is y1 is equal to 0. No, this is y2. As x2 is 4, children, y2 will be 4. Then what is the y1 value? y1 is this one, 40. So it is y1 is 40, whereas y2 is 0. Now substitute the values in this. It is 0 minus 40 by 4 minus 0. 4 minus 0. So it is minus 40 by 4. So it is minus 10 meter per second square. So here we have to write acceleration is negative. Acceleration is equal to minus 10 meter per second square. As the acceleration is minus 10 meter per second, which means what? The body is moving with retardation. Body is moving with a retardation. Simply, children, if the body is moving with a uniform acceleration, we get a straight line such that the angle is acute. Whereas when the body is moving with a uniform retardation, we get a straight line only, but which makes an angle obtuse. This is a point which we have to remember. Fine. So this is a case of actually what, children? Uniform velocity and a uniform acceleration, uniform retardation. Then how the graph will be, how the velocity time graph will be if the body is moving with a variable velocity? Obviously, children, as a body is moving with a variable velocity, that is the case for here is, that is the case of, it is a variable velocity. Variable velocity, or we can take it as a variable even acceleration also. Means what here? The velocity of the body is not changing in a uniform manner. Means randomly it is changing. As the velocity value is randomly changing, obviously acceleration value also will be changing randomly. Then what do we get, children? How the graph will be? Obviously the velocity time graph will be non-linear curve. We will get a non-linear curve. Means what here? At every point the slope is not same. The slope is not same. How can you find the slope? By finding the tangent. Means at a different points we will be getting a different slopes, which means what? The acceleration value will be different. So this is how actually we will get. Children, whenever the body is moving with the variable velocity, hence acceleration, the velocity will be, the velocity time graph will be here non-linear curve we will get. So these are the velocity time graphs. Okay, fine. Now, children, let us see the acceleration time graphs. Acceleration time. The third one and the last one is what? Acceleration time graph. Let us see here. Acceleration time graph. Acceleration time graph. Children, from acceleration time graph, what can we calculate? Can we calculate, children, here the slope of acceleration time graph will give you jerk. What is jerk? The rate of change of acceleration. The rate of change of acceleration. But children, nowhere in examination they will ask about a jerk actually. Just conceptually we will learn. What is a jerk, children? The rate of change of acceleration. That is the slope of acceleration time. Acceleration time is what? Jerk actually. And the important thing is that area. The area under acceleration time graph gives velocity, which means what, children? By finding the area under the acceleration time graph, we can calculate the velocity. So here let us see the case 1. Case 1, let us see here. So children, how the acceleration time graph will be if the body is moving with uniform velocity. It's very important. First case, let us take that as a uniform velocity. Uniform velocity. Children, whenever the body has a uniform velocity, the change in velocity is the same. So whenever the change in velocity is same, children, means of course the acceleration will be 0. So it's very, very important. Very, very important. If the body is moving with a uniform velocity, what is the acceleration value? At every point its acceleration is 0 only. Then how the acceleration time graph will be if an object is going with uniform velocity? Look at here. Children, here is like this. So here is time is taken on x-axis and acceleration is taken on y-axis. Because acceleration is the dependent quantity, time is a independent quantity. Children, here, so uniform velocity means what? At every point acceleration is 0 only. At every point acceleration is 0 only. Means what? Here we will get all points for every point, for every time. After 1 second, 2 seconds, 3 seconds, the acceleration will be 0 only. Means what? When you plot a graph, dear children, you will get a straight line which is coinciding with time axis. Which means what here? Acceleration is 0 at every point. Acceleration 0 means what? The body is moving with uniform velocity. This is the case 1 in an acceleration time graph. Now, dear children, let us see the case 2 where the body is moving with uniform acceleration. Children, it's very important. As the body is moving with uniform acceleration, which means what? Velocity of the body is changing, but what way? In a constant way, in a uniform way it is changing. So here case 2. Here is case 2. The body is moving with a uniform acceleration, then uniform acceleration. How the graph will be? If the body is moving with a uniform acceleration, how the acceleration time graph will be? Look at it. So this is how we'll get. Here is, let us say here is a time. Here is acceleration is taken. Don't forget that it is in a meter per second squares. It is in a second only. So here, for example, here is 0, 1, 2, 3, 4, something like this. And here is some 4, some 8, some 10, something like that. And the body is like the body velocity is changing in such a way that it has uniform velocity. Example, children. Example. So here is at after what we can say at 0 or else. Okay, let us say it's a 0, 1, 2, 3, 4. And how the velocity are going to be? Velocity are going to be, let us say here is 0, 10, 20, 30 and 40. I mean what? After 1 second its velocity is 10 meter per second. After 2 seconds its velocity is 20 meter per second. After 3 seconds its velocity is 30 meter per second. So like that. Now let us try to calculate in this case, children. Calculate the acceleration at any point you can calculate. If you can calculate acceleration in this case, children, the acceleration will be 10 minus 0 by 1 minus 0. So it will be 10 meter per second square. That is fine. If you can calculate acceleration in this case, children, so acceleration will be 20 minus 10 by 2 minus 10. Again it is a 10 meter per second square. Which means what? At every point we get the same value for acceleration. That is 10 meter per second square. It means after 1 second it is 10 meter per second only. After 2 seconds, after 3 seconds we will get, which means what? We get a straight line. We get a straight line parallel to the time axis. Children, whenever the body is moving with a uniform acceleration, we get a straight line which is parallel to the x-axis. But children, as I said that, as we know that the area under acceleration time graph gives velocity. Children, so like this graph is given exam, they may ask you to calculate the velocity of the body at the end of the third second, let us say. How can we calculate? By finding the area. So in this case, let us see here. So this third, let us calculate this line here. So it is nothing but it is a rectangle or a square, whatever it may be, rectangle or square. So let us name it as a O, A, B, C. So by finding the area under this, means area under this graph will give you the velocity, which means what? Teacher, look at here. So how can we calculate the velocity here? Velocity is equal to area under acceleration time graph. Acceleration time graph. So area of what? O, A, B, C. This is here, children, OA into it is OC. OA is what, children? OA is 10 and OC is 3. So that is 10 into 3 is how much is the 30 meter per second. So children, this is how we can calculate the velocity or speed from acceleration time graph. Dear children, so these are the displacement time graphs and the velocity time graphs and acceleration time graphs. Children, the very important things what we have to remember is that the slope means the slope of displacement time graph gives velocity, and whereas from the velocity time graph we can calculate acceleration and as well as displacement. How? By finding the slope of velocity time graph we can calculate the acceleration, whereas by finding the area under velocity time graph we can calculate the displacement. And what can we calculate from acceleration time graph, dear children? We can calculate the velocity. How can we calculate? By finding the area under. By finding the area under acceleration time graph, we can calculate the velocity. So these are the graphs, dear children. And here, children, so one very important thing is that here, for same situations, we may get a, if you for a same situation, if you can plot a displacement time graph, velocity time graph, acceleration time graph, might be different. Don't expect same graph in the same manner for a different ST and a VT and a AT. So I'll tell you one very important. So dear children, let us try to draw the graph for a displacement time and velocity time and acceleration time for an object moving with uniform velocity. Children, it's very important. Let us take here is uniform velocity. So here is uniform velocity. Uniform velocity. Look at here. So how the displacement time graph will be if the body is moving with the uniform velocity, how the velocity time graph, how the acceleration time graph. Children, here if you can plot displacement time graph, we get like this. Time here is displacement, you get a straight line passing through the origin, whereas velocity time graph we get here the time axis is the velocity axis, here is straight line parallel to the time axis, whereas how the acceleration time graph will be. Children, as it is a uniform velocity, its acceleration will be 0 always. So that is acceleration. So we get a straight line which is coinciding with the time axis. So this is how actually, children, again I am saying it's very important. That's what we have to understand the concept rather by hearting. Don't try to by heart the graphs actually here. Very important. So how the displacement time graph will be, velocity time graph will actually. Children, these three graphs will represent the same thing. What is that? The body which is moving with a uniform velocity. Children, how the conceptual questions will be asked. That is how the application questions are asked based on the displacement time graph or it's a velocity time graph. So let us see, children. So for suppose here, let us see one or two examples. Here is one graph is given like this, teacher. Let us see the displacement time graph. It is what, teacher, is the displacement time graph. Displacement, here is the time. Okay, fine. And here is it given that here, teacher, for a two vehicles, teacher, let us say vehicle A and a vehicle B. It is a plotted displacement time graph. We got a straight line as shown in a figure. And it is asked that, children, which vehicle has more velocity? Children, it is a displacement time graph. And there are two straight lines obtained for two vehicles, let us say vehicle A and a vehicle B. Dear children, you tell, just you think, come on, which car has velocity, more velocity? I mean, which car is faster? Either car A or car B, or vehicle A or a vehicle B. Come on, think. Got it? Which car has more velocity? It's very important. First of all, dear children, if you want to tell which car is the faster, you should calculate the velocity. But how can you calculate the velocity from displacement time graph? By finding the slope. It's very important. So let us see, dear children, for a car, for this graph A, let us see, dear children. So it's very, very important. The angle made is theta1, whereas the angle made by this graph, let us say it's a B graph, that is a theta2. So it's very clear that here theta1 is greater than the theta2. I mean, there is a theta represents here slope, of course, that is a tangent only. So here slope, I mean, what is the slope of A is greater than slope of B. So what does the slope of displacement time graph represents? Velocity. So obviously the velocity of car A is greater than the velocity of car B. So children, this is how actually we have to do the analysis here. So whenever displacement time graph is given, if we are asked to find which vehicle is faster or which body has a more velocity, means we have to check the slope. By knowing the slope only, we can say whether it is moving faster or slower. So with this data, we can say that here car A or vehicle A is moving faster than vehicle B. And a similar question will be asked. For example, for a velocity time graph, let us say here is a time and is a velocity. Here again, let us say here the graph is given like this. Both are starting from origin only, let us say. Okay, fine. It is A and a B. Now, dear children, it is asked which car has more acceleration? Children, it is not a displacement time graph. It is a velocity time graph. Which car has a more acceleration means what? First, we have to think, how can we calculate the acceleration for velocity time graph? By finding the slope. By finding the slope, we can calculate the acceleration. Now, let us see, dear children. So, if you want to calculate the acceleration, we need to find the slope. Maybe we need to check which straight line has more slope. Obviously, dear children, look at here. So, this slope is more. This slope, that is a theta1, and here theta2. Children, don't think that here theta1, theta2, here theta1, theta2 same. No. Here theta represents what? It's in velocity. That is what? Slope of displacement time graph. Here theta represents what? The slope of velocity time graph, which means what? Acceleration. So here is theta1 is greater than the theta2. Obviously, the slope of A is greater than a slope of B. Okay. Then we can say that here acceleration of body A is greater than that of the acceleration of body B. So children, this is how actually we have to think in order to answer this type of application questions. Okay children, thank you so much. All the very best.